Hi there, boys and girls, and welcome back to Conquering Math, where it all adds up. Today we will be discussing the independent practice solutions to the prime factorizations lesson. Remember that you can pause or rewind this video as necessary to help you understand the problems. Let's dive on in. Independent practice number 1. Find all factor pairs of the following numbers. A. 24. B. 21. Now is a good time to pause this video and work on this problem if you have not done so already. For the number 24, we start with the first factor pair, which is 1 times 24. 2 is also a factor of 24, so the next factor pair is 2 times 12. 3 is also a factor of 24, so we have 3 times 8. 4 is also a factor of 24, so we have 4 times 6. 5 is not a factor of 24, and that brings us right back to 6, which is already on our list, so we know that we're done. Now the number 21. Start with the first factor pair, which is 1 times 21, and then we try the number 2, which is not a factor of 21, so we have the number 3. 3 times 7 is the next factor pair of 21. 4, 5, and 6 are all not factors of 21, which brings us right back to 7, so we know that we're done. Independent practice number 2. Determine whether each number is prime. A. 8. B. 25. And C. 11. Now is a good time to pause this video and work on this problem if you have not done so already. Let's start with the number 8. The first factor pair is 1 times 8. Using our strategies, we know that the other factor pair is 2 times 4. So we know that 8 is not a prime number because it has 2 factor pairs. Now, 25. The first factor pair is 1 times 25, and again using our strategy, we can find that the next factor pair is 5 times 5. So we know that 25 is not a prime number because it has more than one factor pair. Now for part C, the number 11. We know that the first factor pair is 1 times 11. Using our strategy of checking each other number, we know that there are no other factors of 11. So 11 is a prime number because it has one factor pair, 1 and itself. Independent practice number 3. Create a factor tree for the number 12. Now is a good time to pause this video and work on this problem if you have not done so already. Our first step is to place the product at the top of the factor tree. Then we choose a factor pair and write it underneath the product. We connect with branches. Remember to circle any prime factors. In this case, I chose the factor pair 2 times 6, and I circled 2 because it's a prime number. Next, we repeat this process until all branches end with a prime factor. The factor pair of 6 is 2 times 3. 2 and 3 are both prime, so we circle them, and we see that all of the branches end with prime numbers. So we're done. Independent practice number 4. Use a factor tree to find the prime factorization of the number 30. Now is a good time to pause the video and work on this problem if you have not done so already. The first step is to find the factor tree for 30. I used the factor pair 3 times 10, and I circled 3 because it's prime, and then I broke 10 into 2 times 5, which are both prime. Next, we write 30 as a multiple of its prime factors. 30 equals 2 times 3 times 5. This is the prime factorization of 30, so we're done. Independent practice number 5. There will be 22 people attending a meeting this evening. You are in charge of arranging the chairs. How many possible ways can you set up the chairs in a rectangular formation? Now is a good time to pause this video and work on this problem if you have not done so already. The factor pairs of 22 will represent the possible arrangements of the chairs in rows and columns. The factor pairs of 22 are 1 times 22 and 2 times 11. so we know that there are 4 possible arrangements: 1 row by 22 columns, 22 rows by 1 column, 2 rows by 11 columns, and 11 rows by 2 columns. Remember that you can pause and rewind this video as many times as necessary until you understand the process. Thanks for watching this episode of Conquering Math, where it all adds up. I'll see you next time.